All right. Um, I like that Keith introduced himself a little bit. I didn't have a slide about introductions, but just a couple of short notes on me in terms of what I've been involved in over my career and how I got involved in databases. So I spent spent about 5 years at Apple Computer, and then I spent the bulk of my career at Adobe. And the last 2 years of it, about 15, last 15 years at Adobe, I was involved in cloud architecture, sort of the Adobe's cloud that sits behind all our apps and lets the apps store directly into the cloud. Cloud architecture and engineering. In the last 2 years at Adobe, I spent doing some proof of concepts and prototypes that used, in terms of how we store things in the cloud, that used graph databases as part of the storage model or mechanism for our data in the cloud. And as part of that, we experimented with Neo4j, memgraph, and Neptune. So I have a little experience with all three of those. And then I retired about a year and a half ago, and I was still interested in graph databases. And so sort of my retirement project was, I was going to build a little academic/toy graph database. And I somehow found GQL and got interested in GQL. And then I discovered LDBC, and I joined and became a member so I could get access to the spec and help out there. And Alistair asked me if I wanted to be the chair of the GQL implementation working group, and that sounded interesting, an opportunity for me to be involved with people and still provide some value. And so that's what I've been doing for the last year, of course, part-time. So that's a little about me. So I just want to start with the sort of the mission statement for the GQL implementation working group. It's to create tooling and documentation to assist, to accelerate, to assist and accelerate the implementation and adoption of GQL. And we have a working group charter, of course. We're one of the working groups of the LDBC. And part of our charter outlines the outputs that our group intends to produce. Some of those are in progress, some are complete. Here's a little brief table that describes the outputs that we've been working on and we intend to continue working on and complete. So the first one is an antler grammar. That is in progress / close to completion. We built an antler grammar for GQL, and then I'll talk a little bit more about that in another slide. And so, and then the second one is radio diagrams. And so we have a website or page that you can go to, which I'll show also, which allows you to navigate the grammar using radio diagrams. That's complete. The technology compatibility kit is a set of test scenarios for validating that an implementation conforms to the GQL standard. And that's in the planning. We have some things in place, and I'll talk about that. A specification feedback mechanism. So this is a mechanism for working groups in LDBC to be able to give feedback against the GQL standard into the WG3 working group. And I'll talk about that. And that's complete. I mean, the mechanism is complete. We continue to produce items in that mechanism that's feedback to the working group, the D3 working group, WG3 working group, sorry. And then finally, the technical report. So as you probably most of you know who've seen the standard, it's a very difficult read. It's written to be able to specify a language, but not necessarily an easy read. And so it's not meant for either users to learn how to use GQL, or even as the easiest way for implementers to learn GQL. And so the idea with the technical report is to produce a document, and I'll talk a little bit about what we're doing there to make it easier for people to consume the spec and understand, not the spec, but to understand the GQL language itself. And that's in progress. All right, so the first item, the Antler grammar. So we in our working group produced an Antler grammar for GQL, and we do have, by the way, we do have I'll hop over to this real quick, but we do have an open GQL GitHub organization, and there's several repositories in there. One is the grammar that we've produced. And here's just the repo for that, and you can link for these from the slides when you get these slides. And the intention that was an interim grammar, and I'll talk a little bit about that, more about that in the next slide. Currently, that grammar drives both the code editor and the radio diagrams. I think I skipped talking about the code editor, but I'll talk about that in a few slides here. So we hired, not for pay, but we've exchanged some work that we're going to do for them in terms of marketing collateral and so forth, and they are doing some work for us. Strumenta is a group that specializes in language engineering, and they are Antler experts and language experts, really parser experts. And so we're working with them. They've taken our interim grammar, have enhanced it and tested it some more, and are actually have built a Kotlin/Java parser with an AST, and they're going to build a Python parser with AST output for us to use also. And you know, we started with a kickoff meeting with Strumenta. We sort of shared what we learned with them in developing our grammar, and they've given us weekly updates on their progress, and it's been great. They did a great job for us. They were not able to make this. We wanted to give them an opportunity to share the work that they've done. And so they produced a 10-minute video for us. I hope this works. I'm going to switch over to QuickTime. The audio is not as loud as it could be, so I hope you guys can hear it if you listen really closely. Let me switch over to QuickTime.
Greetings everyone, my name is Alessio Stalla, I'm a language architect at Strumenta, and I'm here to talk about the collaboration between...
Can you guys hear that?
Yes.
Okay, great. Okay, I'll continue, and I'll just shut up.
LDBC and Strumenta to build an open source GQL parser based on Antler 4. First, a few words about my company, Strumenta. We are a company specializing in language engineering, and by that we mean that we build tools and libraries to work with programming languages. So those include parsers, legacy modernization efforts, where we help our clients migrate legacy code bases and migrate away from legacy platforms to modern languages and systems and tools and IDEs and so on. And we also develop tailor-made domain-specific languages with all the tools that accompany these kinds of projects. So, for example, editors, linters, type checkers, transpilers, interpreters, and so on. The company is registered in Italy, but we have employees all across Europe. We are a fully remote company, and our clients are mostly based in the US and Europe, but we've had some Asian and Latin American ones too. So, in this project, our objective shifted during the course of the project. So initially, we were tasked with writing an Antler parser starting from the BNF that is part of the GQL specification. So the BNF is a formal definition of the GQL grammar that is suitable for human readers, and also for some kinds of automatic verification or translation by tools, but it's not directly fit for generating a parser, so an actual software library that can be used in programs to recognize GQL code and obtain a high-level structure from a code string. LDBC chose Antler as a parser generator, which is also the parser generator that we typically use and that we are experts about. So this was naturally a good fit. However, as I said, the objective shifted because while we were negotiating about the project and getting to know each other, LDBC, in the person of Michael Burbidge, actually produced the first translation of this BNF into an Antler grammar. And so our task became twofold. So on one hand, we were tasked with validating the Antler grammar provided by Michael and by LDBC, and then to build an open source parser on top of it, following our best practices that include designing an abstract syntax tree on top of the Antler parse tree, which is the parse tree is a data structure that is lower level and closer to how the parser works and how the grammar is written, while the AST is a higher level structure, which is still tree-based, but it can better reflect the mental model that developers have of the code without all the accidental complexity that derives from having to write a grammar that has to be compiled into a parser. And then we also addressed some non-functional requirements that I will briefly talk about. So starting from the Antler grammar, I must say that the grammar that Michael produced and that LDBC provided was already pretty good. So it's a big grammar, even in our experience with complex languages. So we couldn't go over it entirely by hand and reading it, but we tested it automatically, and we had to introduce just a few modifications to fix a few issues, minor issues, and we restored some provisions for implementation specific extensions that were present in the BNF but had been removed in the Antler for translation. Of course, more testing is needed, but we think the grammar is already reasonably good. Speaking of tests specifically, we ran two kinds of tests. First, we tested all the code, all the GQL code found in the TCK that LDBC provided us. And all these tests pass, but I must say this: the test cases that are included are a small number, so that by itself it's a good result, but doesn't give a high level of confidence in the quality of the parser. Then we also tested the parser on roughly 13K randomly generated GQL programs or queries and statements, and again Michael and LDBC provided these test cases, and of these close to 90% pass. So there's still some work to do, but the parser is already working quite great. And as I told you before, there are some non-functional requirements that we tried to address too. So these are especially usability and ergonomics. So by using the AST, by defining and providing this AST, we want to make the parser easier to use. So this AST was prototyped with our proprietary tools called Starlazo tools that from an annotated Antler grammar can generate an initial version of the AST that then will refine by hand. And this AST is built with an open source library that we developed called Colazo, which already comes with a rich set of features, including methods to traverse the AST, to modify it, to serialize it into a number of formats, including EMF and LionWeb, and more. So we believe that with this extra layer on top of the bare Antler 4 parser, the usability and ergonomics of the parser is greatly improved. Regarding performance, at a cursory glance, performance seems quite good already, but we must say that measuring the performance of a parser is not a trivial task. I'm sure everybody will, or most people will know that. That's because we tested the parser on a large number of randomly generated examples, but those don't necessarily represent the typical code that the parser will be used on. So to show meaningful results, we would need one, to test the parser on the typical common cases, the code that is most often used, the recurring patterns that users typically write, and it should be heavily optimized on those. And at the same time, it should handle corner cases reasonably well. So that means that there shouldn't be any query or statement that is too big or too hairy to the point that the parser will halt or slow down to a crawl or even crash because of exhausted memory, for example. And finding and testing these corner cases is hard, and that's one of the reasons behind open sourcing such a parser, because then users can independently test the parser against the kind of queries that they expect to encounter, and then they can independently report issues that we can then fix. This is enough talking on my part. I will just briefly show the parser in action. So I will show a small demo. Of course, a parser is a software library, so there's no much visualization happening, but we can show the test suite running, and this includes the TCK and the randomly generated examples, plus a few manually written tests that we included to verify some regressions that we were having. So this test fuzz programs case is by far the lowest one because it's testing all 13K and more examples, and we'll see that it takes several seconds to run, but it's a pretty reasonable time considering that it's parsing, it's opening each file, parsing its example, building an AST for each of them, and it's taking like 2 milliseconds per file. So for a first version, this is reasonably good, and we can see a bunch of these tests fail with some syntactic issues. So we can also see how error reporting works with this parser. The way Antler is built and the way our own tools on top of Antler are built mean that as a parsing error does not result in an exception does not result in the control flow being interrupted. Instead, we collect all those issues, and then we, in this case, we print them, but user code can react to them however the application requires. So thanks for thanks for following so far, and the parser will be open sourced soon, and so I hope you will check it out. Thanks. Bye.
All right, so, whoops. Can you guys hear me still? Oh yeah, you guys can still hear me, right?
Yes.
Yeah, okay, sorry,
Okay.
okay. Let me go back to play. Okay, so as Alessio mentioned, this is all going to be open sourced and will be part of our the LDBC Open GQL organization. There, we just barely received the work that they've done this week, so we need to get with them and figure out how we get it over into our repositories and stuff. And as I mentioned, future work would be a Python parser with the Python AST also. All right, so the next one is the Antler, the GQL code editor. So this is just a code editor that lets you enter GQL programs, and it syntax checks them. I should say that it syntax checks them based on the grammar, so it doesn't implement syntax rules such as multiply defined variables and stuff like that. It is purely a syntax check, but still it can be very useful. And it is generated from it uses the Antler grammar in the OpenGQL repo, and it's automatically deployed. A new version of it is deployed whenever a new version of the grammar is created in the grammar repo. It contains a bunch of GQL examples, so just quickly, I'll run over to the examples. So just not a lot, but a handful of simple GQL examples. You can click on any of these and you can see that it says there's no errors. If I actually create an error, you can see that there's errors there. It also does type ahead or autocomplete. Sorry, whoops. Back over there again. So you see if I say match, I can do autocomplete and return, so forth. And so anyway, I think it's a very useful tool for those who are trying to get started with GQL. And it's great to have. As part of working with Strumenta, we sort of realized, and they asked, do we have samples that they can test against? And we don't really have that many samples. So we did a bunch of research and looked at different ways to build a grammar-based fuzzer. It turns out there's a bunch of papers written on this kind of stuff, and so I looked through these papers and after reading sort of the abstracts, I narrowed down on this one called systematically covering input structures. And the thing that's nice about, and there's an implementation that goes along with this. So this implementation takes a grammar, and then you can run, using a grammar, you can run it to produce a bunch of random examples that conform to that grammar. It solves two really nice problems that are hard to solve. One is it limits recursion. So as you know, grammars like GQL are highly recursive, and figuring out how to produce examples while limiting recursion is difficult. And the other thing is it guarantees to cover the grammar. So in other words, when you run it, depending on the parameter inputs you give it, but you can run it in a mode where it will generate enough examples to actually cover the grammar. And so that's a really nice characteristic. Basically how it works is I built a little program. Well, it takes a grammar called EBNF. It's similar to EBNF, but it has their own style. Anyway, it takes a grammar in this EBNF format and produces, and then you give it some parameters that you control how it works, and it produces a set of GQL programs. So I wrote a little program called GramGen that takes the GQL BNF and produces the Tribble eBNF. And then I had to do some hand tweaks to it, particularly around white space rules, because the GQL BNF doesn't really contain, it contains some text about white space, the standard does, but it's not really in the grammar. And then that ended up with the Tribble eBNF that we run through Tribble. So if we run Tribble with kpath, it's one of the parameters you give to it. It basically, it's among other things, controls or limits recursion. If you run kpath of 5, it generates 14,000 GQL programs that theoretically covered the grammar. If you enter kpath greater than 5, of course, it results in more recursion. So the samples are going to be bigger and demonstrate more recursion in them. So that's that one. This might be useful for folks out there. That's why I mentioned it. It's not one of our outputs, but if you're working with GQL and trying to build a parser and you want to be able to produce samples, this could be interesting to you. And I'm going to try to get it up in to our organization also. And then the next one is railroad diagrams. We have built railroad diagrams. They are driven by the ANTLR grammar. They support link-based navigation, back button support, and again, the website is the page is automatically deployed when new versions of the grammar are created. So if we just go look at this real quickly, let me go down to one that's more interesting. So procedure specifications. I can go to procedure body, and then if you hit the back button, you go back up to procedure specification. Just this navigation is really helpful. It's hard to navigate through the standard, the grammar in the standard. So that's really helpful. The GQL standard feedback mechanism. So this again is the mechanism for the LDBC working groups to provide feedback to the WG3, ISO W3G working group in terms of changes to the standard or improvements to the standard, etc. It's simply a Google Doc. If you go flip over here, this Google Doc explains there's one entry for each change that we're recommending or that we're trying to get WG3 to look at. And the top of the document explains each of the fields in each of the improvement proposals. And there's already, I think there's 13 in here already. The idea is that WG3 has agreed to look at this document regularly. So people in LDBC can post new improvement proposals, and WG3 will look at this on a regular basis and consider them for improvements, either as part of the version 2 or as smaller fixes that they might make to the standard in the interim. Technical report. So we're working on two publications as part of the technical report effort. Let's see, the first one is a 6 to 8 page summary of GQL. The target publication for that is communications of the ACM. So we're trying to get a very broad, get that into the communication of the ACM so that we can get very broad readership. A draft is going to be available mid-September. And then we're working on longer, more in-depth summary of GQL. The target publications are transactions of databases, on databases, sorry, or the LDBC website. And this document hopefully is very example driven, and it's in progress. We don't really have a date for that one yet. And then the TCK is the last thing I'll talk about. So the TCK, that's a test, it's essentially a compatibility test kit, or the OpenCipher, if you guys are familiar with OpenCipher, it has a TCK, which is a collection of tests, or they call it scenarios, that validate that an implementation conforms to OpenCipher. The GQL TCK is a set of tests that validate that an implementation conforms to GQL or one or more of its optional features. We want to complement the work doing in the Lex working group. So I think Alistair is going to talk about the catalog schema and graph type work that they're doing. And so we want to complement that. And we also want to complement the work that Neo4j is going to do with OpenCipher and moving it towards GQL. And Valerio is going to give a talk on that later today also. And so in terms of prioritizing our work, in terms of the scenarios that we will be addressing, we're going to start with catalog test scenarios to sort of complement the work being done in the Lex group. And then the DML, or the data modification test scenarios, because those sort of relate to graph types. And then we do want to continue to pick low-hanging fruit, the OpenCipher test scenarios, those scenarios that are easy to move from OpenCipher over to GQL for queries, expressions, and other low-hanging fruit scenarios that are over there. And we're going, we'll work with OpenCipher, perhaps making change requests to OpenCipher that make it easier for us to reuse their scenarios. And the sort of the reuse model will be we copy them, modify them, as opposed to trying to reference them. So we'll copy, make hopefully small modifications, and they end up in the GQL TCK. Progress to date, you can go look at the GQL TCK. It's like Alessio mentioned from Strumenta, it's very minimal right now. There's a design architecture README that is probably the most useful thing. There's a skeleton layout that contains the test scenarios that we've done so far. Some sample catalog scenarios and then we've moved over. It contains currently some sample catalog scenarios and a few different kinds of scenarios that we've moved over from OpenCipher, some expression scenarios, and a few match scenarios. We just started that work. So contributors are welcome. We need them. A TCK for GQL is going to be a large effort. We're going to have I'm calling it a restart kickoff meeting because we've been sort of wrestling with strategy for the TCK over the last few months. So in September, I hope to have a restart meeting just focused on the TCK. We'd love to have your participation and contribution. So if you're interested, please email me. And there's my email address. And that is it. I have probably not time for questions. I know I'm just maybe 5 minutes over.
Any questions?
All right, thank you. Go ahead.
I got a quick question for you. Could you a bit elaborate on how the vendors can contribute to the GQL TCK?
So the first way that you can contribute is by attending this TCK kickoff meeting. And we had one of these back about 6 months ago, but again, we've been struggling with strategy over the last few months. I think we've arrived at the strategy we want. So I think the kickoff meeting would be the best way. And certainly taking a subset of scenarios and working on those scenarios in GQL, a subset might be, a particular feature of the GQL language. We certainly have to coordinate that. I think the working group meetings are the way that we would coordinate that. And so attending the kickoff meeting and helping us formulate a plan for how you want to contribute and how you can contribute would be the starting point, I think, for that.
Okay. Okay. Thank you. Uh,
Yeah, can I just
All
add
right,
to
great,
that?
thanks.
I mean, I think
Yep.
that there was a paper by Don Chamberlain looking back at the history of SQL. He pointed out that NIST had an SQL test suite, which in the earlier days of SQL was actually really fundamental to making SQL successful. OpenCipher's specification really is the kind of operational semantics represented by the comprehensive TCK. If we don't get a TCK for GQL, it's going to prejudice for everybody, every implementer of GQL, the effectiveness of this new standard. So I really would like to ask companies, projects that are looking at implementing GQL to seriously consider getting involved in the work that Michael's leading. It's to the benefit of everybody. It's the next phase of the kind of multi-company collaboration that led to the standard in the first place. And use it and build it, because every time you use a TCK in your test for your product, you're going to actually help the entire community. And I think that's a great opportunity. The work that's been done already is an amazing start, being done by volunteers who are not being paid by anybody. And if you've got paid engineering resource working on this problem, please contribute. That will actually make a big difference for everybody.